My name is Roger Rothkamp. I work at the NASA Johnson Space Center. I'm a robotics engineer, currently working in an emerging field called wearable robotics. People are becoming more comfortable with the man and machine becoming closer together. In the past, there may have been hesitation or the technology wasn't there, it wasn't compact enough. But now we've kind of reached a tipping point of sorts where all this technology is coming together at the right time, and we're seeing a lot of applications for it, especially in spaceflight. The lower extremity exoskeleton is a wearable robotics. It's got 4 active degrees of freedom and 6 passive degrees of freedom. The applications are in assisted mobility, human augmentation, exercise, and applications that we haven't thought of yet. There are a lot of terrestrial applications. One very important application is assisted mobility, so we can assist people with paraplegia or just weakness and things like that. A key component of this project was the opportunity to work with some people that had paraplegia. The moment we got to work with them and kind of see just the energy they had to put into what we were developing, it's just exciting. I mean, there's so many applications, and you get the opportunity to work with such great people, and you get to help people. Can't beat that. We're very proud of the glove. The technology for the glove was developed in collaboration with General Motors. And with General Motors and NASA working together, developed 44 patents. And some of those patents and that technology was put into the glove to assist assembly line workers in manufacturing plants. It's dynamic. Even spaceflight is just a great cause. And now we're being able to apply that to terrestrial applications. And that just makes it that much more exciting for me. I love it. Anything you can do to make life better on Earth.
NASA is sending a new Earth research spacecraft into orbit to measure and map the moisture within our planet's soil. The Soil Moisture Active-Passive mission will use remote sensing instruments to create global maps of Earth's soil moisture, helping us better understand water and carbon cycles. SMAP will get a boost into polar orbit aboard a United Launch Alliance Delta II rocket launching from Vandenberg Air Force Base in California. The first stage of the Delta II pulled into Building 836 on July 23, 2014. It was offloaded and moved to the horizontal processing facility at the launch site. On August 4, the first stage moved out to the Mobile Service Tower at Space Launch Complex 2. A crane lifted the booster into the vertical position, then the interstage adapter was installed on the top. The rocket's 3 solid rocket motors were attached to the first stage on August 18, and 2 days later, the booster was topped with the second stage. Once inside Astrotech, SMAP was put through a series of inspections and tests to ensure it's ready to perform during its 3-year mission. The spacecraft wrapped up its pre-flight processing in mid-November. Final preparations began in the new year. SMAP was joined to its launch vehicle hardware on January 7, and during the following days, it was bagged in a protective cover and placed into a canister for the move to Space Launch Complex 2. The observatory was transferred to the launch complex and hoisted into place atop the Delta II rocket on January 13 and secured inside the protective payload fairing later the next week. Each of these milestones sets the stage for success as NASA sends its newest satellite on its mission to map Earth's soil moisture.
NASA scientists have performed the first multi-year study using satellite data to measure the 3D distribution of dust that travels from the Sahara Desert to the Amazon rainforest. The Sahara is the world's largest desert. At more than 3 million square miles, it's almost the size of the continental United States. Each year, Saharan dust is lifted from the ground and transported by winds on a 3,000-mile journey across the Atlantic Ocean. A portion of the dust collects in the Amazon basin, the largest rainforest on the planet. Although dust particles are small, no larger than around a tenth of the width of a human hair, they form massive plumes that can be seen from space. NASA's Calypso satellite was launched in 2006 to study the vertical structure of clouds and particles in Earth's atmosphere. Calypso observations from 2007 through 2013 show that on average 182 million tons of dust leaves Africa each year. Of this amount, about 27 million tons is deposited in the Amazon basin.
Sahara dust contains phosphorus, which is an important nutrient for plants. In the tropic region, the phosphorus is quite limited, so it's important to estimate how much dust from desert is transported to the Amazon.
The study shows Saharan dust adds phosphorus to the soils that help compensate for losses due to surface runoff and floods. However, the amount of dust transported to the Amazon changes from year to year. According to the study, this variation is closely associated with changes in rainfall in the Sahel, a belt of semi-arid land just south of the Sahara.
When the Sahel was dry, the dust transport to the Amazon in the next year would increase. When it was wet, dust transport will decrease. Using satellites to get a clear picture of dust is important for understanding and eventually using computers to model where that dust will go now and in future climate scenarios.